Okay, folks. We'll get started on aeronautics. And we've got the aircraft poll. And there is a question here already in Q&A. We'll save that one for space because it is a space one. And space capital intensive projects and SLS, specifically whether it surpassed space shuttle yet. Obviously, that's an interesting question that has probably about 12 different answers, depending on the way you ask it. So just join Slido. We'll get started, and we'll go from there. Okay, so since we're in this weird place, so why is the June bug famous? And it's famous, of course, as we said, because it is the first aircraft to complete a circuit of greater than 1 nautical mile. So think about what that means. When the Wright brothers did their first flight, they couldn't even take off under their own power. It required a catapult. They flew basically in a straight line. Now, that's important because to fly sustained in a straight line is a big deal, especially with an aircraft that's marginally stable. You have to have the ability to control it to keep it from pitching up and crashing. But flying a circuit involves taking off, climbing to an altitude, leveling off, being able to do turns, and then landing again. Now, this was in 1908, and it flew far more than a nautical mile. And it just showed that we now went from a machine that was basically capable of the most basic powered sustained flight to something that's going to become practical. Now, we couldn't carry much of a payload. It just carried the pilot. So we're talking about things like observing and the like. You couldn't carry, say, bombs or mail, which was the next big step. But it gets there. We're getting a big step up in that. So that was the June bug. Now see if this works. Ah, crap. What's going on here? So what makes the Boeing 247 important? And it was the first stress skin low-wing monoplane. I like how this is revealing my answers before I get a chance to reveal the answers. So what is it about that? And why is that important? Before the 247, all of our aircraft were either wooden framed, draped in dope fabric. We were getting metal frames, so tubular steel and the like that were welded together. But what that means is as the aircraft gets bigger, we have two problems. One is drag. All of that fabric or ribbed metal that we use creates drag as we go faster. The other problem is the aircraft is actually quite heavy for any design. It works really well when you're on small aircraft where you're minimum gauge, so things like a Piper Cub. But as we get to larger and larger aircraft, anything we would have today, if we don't use the skin to carry the load, we're just adding weight. So this aircraft, that skin, that semi-monocoque construction that we see today with stress skin, stringers that run lengthwise on the fuselage, frames that go around, stringers that run spanwise on the wing, and ribs in the wing to hold the form. This is that first time that's all been brought together in one aircraft. It was retractable gear. Now, it wasn't very successful for the main reason is, if you look on here, this one says United Airlines. And Boeing had started an airline in the 1920s, and then they went to Pratt & Whitney, who made piston engines. It was one of the two large piston engine manufacturers in the US. The other one was Wright Aeronautical, as in founded by the Wright brothers. And they decided they wanted to do a totally vertically integrated system. So they would make the aircraft, they would make the engines, and they would operate the aircraft. So they formed a company called United Aircraft and another company that was wholly owned subsidiary called United Airlines. Now, that meant they built this aircraft and these engines solely for use by United Airlines. They thought, we're going to have a monopoly, we're going to dominate the market. Well, the other airlines didn't like that because there were lots of other airlines, and they sued. They went to the federal government, and the federal government sued an antitrust court, and they were broken up. And to this day, you are not legally allowed to build, power, and operate an airline in the U.S. because of that. But because of that, no airline wanted to buy this aircraft because they thought, well, Boeing still owns part of United Airlines, so they're going to favor them. So they went to another company. Anybody know what company that was? And they asked them to build something a little bit better. And they came up with, first, the DC-2, and then the DC-3. And this is, we talk about the DC-3 as the first universal aircraft built. Now, the reason why the DC-3 became so ubiquitous wasn't because it was a great aircraft. It was. We're still flying them today. You see them in the bush in Alaska, in Africa, flying cargo and the like. It's because something else intervened and someone else ordered a ton of them, as in 10,000 plus of them. And that would be the U.S. Army and other things the U.S. government donated them to. So the U.K. had theirs. I believe they called them Dakotas over here, if I remember correctly. Or no, Dakota in the U.S. And then when the war was over, they were surplus. We didn't need them. So they basically sold them at scrap value to airlines. And they became the backbone of the modern air transport in lots of the world. They've just been cascaded down. Now, they're brilliant aircraft. They don't wear out. They don't break in the same way. They're not like modern commercial transports. You can fly them forever. It's only when things like engines go wrong and the like that you have problems. Bang them, crash them. So, less than 400 DC-3s were built. In the truest sense of the word, true. But the C-47, which was then back converted to DC-3s, they built thousands and thousands. So it depends what you mean by built in that sense and the like. Okay. What were the primary reasons Boeing developed the 367-80? It was two things. One is they need refueling capability for their bombers. The U.S. Air Force didn't even come to them to ask them to do it. The U.S. Air Force was flying piston engine tankers to refuel their high-performance jet bombers. They barely worked. One was firewalled, and the other one was about to stall, but they were fine with that. Boeing came in and said, we can do better, and at the same time, they knew the airlines looking over to the UK and seeing the Comet being developed wanted something a lot better. So they developed the 367-80 with their own money, what's called IR&D money. So basically, at the time, and still to this day, every U.S. military contract, there's an extra percent. I think it's roughly, at the time, it was about 10% added on to whatever it cost you to make that. So if the development program cost $100 million, they gave you $110 million. And that 10% was to the company to do whatever they wanted with, what was called internal research and development. So Boeing had accrued a lot of IR&D money during the Second World War in the 1940s and early 50s on the B-47 and B-52 programs, and they basically spent all of that on the 367-80. Pan Am and TWA ordered a bunch. The U.S. Air Force, they convinced them to order a bunch of what are now C-135s and KC-135 tankers, and all was good. Except for that pesky Douglas Aircraft Corporation came around and said, aha! The Boeing design only seats 5 across. Our design seats 6 across. So for the same space, you can put in 1/6 more, or 1/5 more people. 6 to a row instead of 5. And TWA and Pan Am went back to Boeing and said, we're going to cancel our orders. But at the last minute, they were building fuselages. Boeing retooled their line, increased the diameter of the fuselage to fit 6 across. Actually be slightly larger than Douglas. At the last minute, and then built the 707. So the 367-80 is not a 707, even though they put that on there. It is a slightly different aircraft. This is the aircraft that was famous for doing a barrel roll over the Seattle Boat Show in front of all the Boeing executives and the like, just to show that it was capable of that performance and the like. Okay. What is the best-selling certified aircraft of all time? And yeah, it's the Cessna 172. I think the A320 will soon eclipse, in terms of total sales, the 737. It didn't help that Boeing designed one that decides to lawn dart itself. But the biggest reason that these jets sell a lot more over time, the 37 and the A320, than the 727, is we've just got a lot more air traffic. But the 172 is the king, even though Cessna had to basically stop making them for 20 or was it 10 years. They basically made too many, and they needed them to crash out and build more. So they built over 40,000 of them. Okay. Okay. Which of the following facts about the B-29 are true? Seems to be working a little better in this case. Was it the most expensive weapons program of all time, at least at the time it was completed? It cost more than the Manhattan Project. More B-29s were lost to engine fires than enemy action. The Soviet Tu-4 was started out as a part-for-part copy. It can be traced to the birthplace as a birthplace of systems engineering, and it met its original performance requirements. See if this works properly. No. So, the only one that isn't correct in one way, shape, or form is it met its original performance requirements. For some reason, it says that's correct. That would be me. So the B-29 was quite an interesting program. The U.S. started it with the idea that the UK would fall and that they would have to be able to bomb Germany from Newfoundland, at worst, hopefully Iceland. So this was designed as originally spec'd as a transatlantic heavy bomber. That was far in excess of any aircraft's capability at the time. It had to carry a 5,000 plus pound bomb load across the Atlantic. Bomb and then return, hopefully to Iceland. Now, they went out and they put out the contract, the request for proposal to Boeing and Douglas and Consolidated Aircraft all responded, and this one was selected. Now, the main reason it was selected is that Boeing had some technology capabilities that they had been trying out on other aircraft that they rolled into this. At the time this program started, the U.S. was not what you would consider an aeronautical leading edge country. They had pretty robust, relatively speaking, but crude engines, nothing like the Merlin in the UK, no fuel injection, they were carbureted. These were large, heavy, but generally robust radials. However, they did have two technologies that they were the leader on. The first one was turbo supercharging. And the reason why turbo supercharging is so important, if you're going to design a high-altitude, long-range bomber, you need to be able to add power to your engines as you go up in altitude. As the air density falls, the power capability of the engine falls dramatically. If you boost that engine, you can keep that power. You can also do what's called overboost, which is what we do in our turbocharged cars, and that gives you more power at low altitudes and the like. Now, there's the main way you do that is what's called a mechanical supercharger, and all these engines actually had them. The problem with the mechanical supercharger is the higher the altitude, the more power it draws out of the engine. So at some point, it takes more power than it gives. But a turbo supercharger, by using purely exhaust gas waste, doesn't have that problem. So you can actually boost it. You can get much better high-altitude performance. Now, why is that important? Well, this was a high-altitude bomber. What was the next technology that they put in there? This was also pressurized fuselage. So if you see film or footage of the American high-altitude bombers, the B-24, the B-17, things like the Lancaster and the like, they were unpressurized. When they were flying at 25, 30,000 feet, you were there in the minus 50 degrees Celsius, having to be all wrapped up. In fact, they use electrically heated suits to keep the crew warm. This was a short sleeve environment. You could fly for much longer in that comfortable environment than you could in something like a B-17 or a Lancaster. Add to that, it has automated or semi-automated fire control for its guns. None of those things worked as planned. The B-29 was typically limited in range, not by fuel capacity, but by oil capacity. The problem with that is the engines spewed so much oil, they would spew oil onto hot exhaust manifolds and other magnesium parts. It would catch fire, go to the wing spar, burn through the wing spar, the wing would fall off. The program itself took so long to complete. It was started in 1939, went into service in late 1944, that it ended up costing more than any weapons program the U.S. had ever devised. It was about 50% more expensive than the Manhattan Project. The original B-29s and the original place they flew from didn't have the range to make it back if they were at all damaged, so several of them flew on and crash landed in the Soviet Union. The U.S. asked for them back. Stalin said no. He had them disassembled and copied part for part to create their first big, large, heavy bomber, the Tu-4. It was such a faithful copy initially that it had all of the same problems of oil consumption and oil spilling and wings burning through and falling off. And the U.S. slowly fixed most of those and improved the reliability, and the Tu-4 didn't. It was such a touch-and-go program that the science advisor in the U.S., Chief Science Advisor Vannevar Bush, called for a conference on how to do this better in the future. And that was where systems engineering came from, and that met its first big test in the Apollo program. Because if they had have done it like the B-29, there's no way they could have made Apollo work. Okay? These are some also-rans, and they're in a bit of an order, and they've lost it. So in the top left is the XB-70, then we have Concorde, and Tu-144. Now, I put them in this order because that was the order in which they started development. In terms of going into service, this aircraft went into service first because they wanted to, probably too early. This one went into service and had a much longer service, and that never went into service. And it's because they have, of course, different design things. The XB-70 was designed as a 5,000 nautical mile radius intercontinental heavy bomber that would cruise at Mach 3 and drop its 25,000 pound nuclear payload unsuspectingly on poor people below. And two things made that less practical. One was the advancement of surface-to-air missiles. When it started, it was untouchable. By the time the program would have entered service, it would have been vulnerable. And the other one was the development of ICBMs, space launch. Why take several hours to get somewhere when I can get there in 35 minutes? So I can deliver that with equivalent accuracy off an ICBM, or even more importantly, out of a submarine, and get less notice and harder to detect and harder to avoid. But the beauty of this is NASA took over the program, did lots of flight testing, and released data to the world. And you can go on to this day onto the National Technical Report Server and download all sorts of information about the XB-70. There's some stuff you can't, but things like handling qualities at Mach 2 and Mach 3 are publicly available and were made publicly available. Now, the rest of the world loved that. We got our supersonic transports in Concorde. These were, in a sense, dead ends. Concorde never made enough money to pay its development costs. British Airways bought each of their 14 or 7 for £1 each. and made money operating them, don't get me wrong, until, of course, the accident, and then the retrofit, and then they became a big cost sink and never made enough money. Okay. So we have rotary. Let's talk about launch vehicles. So there's the space survey, and we'll do a little bit on launch vehicles here for a second. Oh, there's some great questions here on space stuff. In fact, they're all on space stuff, which is great. We'll talk about them, some of which relate back to the XB-70 program and its advantages and disadvantages. Okay, we'll start with the space survey. Which launch vehicle was the first to reach over 100 consecutive successful launches? The Delta II, Atlas V, whatever I just copied again, Space Launch System, Falcon 9, or Ariane 5. And it is the Delta II. It had the 100th consecutive successful launch on its last mission. Now, that doesn't mean every Delta II vehicle was successful. They had a failure in the mid-1990s, and it was in 2018, I think, was when they got to 100. It was kind of the workhorse for a lot of NASA exploration. So a lot of Mars rovers and stuff were launched on it. Did other communication satellites. It wasn't a very large rocket, but it did form a workhorse. As such, which vehicle currently holds the record? And it is the Falcon 9. So it surpassed the Delta II, and I'm going to get this wrong. I believe it was in June of 2020, or was it June of 2021? I always forget when it happened because my brain has mixed those 2 years completely. And it went to 101. It's continued going. It hasn't had a failure since then. I think they're going to launch probably about 30 of them this year. So it's well, far and away the longest continuous successful run. At the rate they're going, they will actually probably, this was supposed to be Soyuz and the like here is what that was supposed to be. They will probably surpass the R5 in total uses before they retire it. The R7 derivatives. And the like. So here's an interesting one. What about that record-breaking Falcon 9 launch was special? Record-breaking, Apollo 11. Any other thoughts? To give you a little bit of a hint, it was special to us here at the University of Manchester. It was a NASA commercial resupply mission for the space station, so Cargo Dragon was what the primary mission was. This is the 101st consecutive successful launch for the Falcon 9. It was the launch on which the University of Manchester satellite SOAR was put into space. So it just happened that we were all watching it that day, and it was both successful as the Falcon 9 and then ultimately successful docking. We had our satellite deployed from the space station. It's orbiting now, and we're getting our data. Next year, when you take Space Systems, folks doing that will talk to you more about that program. It's a very low Earth orbit. Right now, it's sitting up higher. Design, it's characterizing both materials in low Earth orbit, but also controllability. It's got steerable fins, and they're doing flights around that. Okay. What is the single greatest achievement of manned spaceflight? Scientifically, this is a your opinion type thing. Was it the International Space Station, the Hubble Space Telescope, Apollo 11, Salyut 1, Vostok 1, Gemini 6, Apollo 10, or Skylab? Now, I put all of those up there for one reason or another. ISS is the single most expensive, most complex man-made single object there is. We've spent well over $200 billion on it. Yeah, I mean, a billion here, a billion there. Eventually you start talking about real money. It's been in orbit and occupied continuously for longer than any other space station. And it's got lots of capability. Hubble Space Telescope sits in a land of its own. Since it was launched in the early 90s, it has contributed more to the knowledge of cosmology and physics than anything else NASA has ever done. shot. Maybe it will finally be replaced. Hopefully James Webb will not blow up and it will unfurl. Only, 5 or 10 years too late. Salyut 1 was the first space station. Vostok 1, of course, first man in space. Gemini 6 proved you can do docking. Apollo 10. Anybody know why Apollo 10 is on there in addition to Apollo 11? What is it about Apollo 10 that's important? Apollo 8 would also be up there. Apollo 10 was the one that proved that you could go somewhere else, undock another spacecraft, maneuver it, get into line for landing, and return. Apollo 8 was the first mission to actually leave Earth's orbit. Skylab was the first U.S. space station, and Apollo 11, obviously, is actually landing on another body and returning safely with humans on board. I would say personally, if just looking at it from a scientific point of view in the papers, Hubble is by far and away the biggest contributor of manned spaceflight, but each of these have their own. I'm not personally a fan of the ISS because I think the budget cuts have basically rendered it not useful for what it was originally supposed to do. Okay, there's a reliable one. So this is the Delta DCX. This is probably the most substantial single advancement in terms of rocket design that we've seen in the last 40 years. This is what has laid the groundwork for Falcon 9, Super Heavy, Starship, New Shepard, New Glenn. This was the first rocket that took off vertically, flew some distance, either up or out or horizontally, and returned and landed vertically successfully and was reused. Now, it wasn't a space launch vehicle. This was done on a budget of, I believe it was about $10 million by McDonnell Douglas back in the 1990s to interest them in their design concept called the DC Clipper, which was a single-stage to orbit, reusable launch vehicle. Unfortunately, NASA was not wooed by practicality. They liked sexy. They liked Lockheed Martin's horizontal takeoff and landing, single stage to orbit design, and spent a lot of money on something that went nowhere. It is probably realistic that if they had funded this program and this design concept, we would have reusable single stage to orbit launch vehicles today. Whether they'd be cost effective compared to something like Falcon 9 or potentially Super Heavy and Starship in the future, I don't know, but technologically it was capable and possible. But when they didn't fund it, Douglas didn't have the money to do it on their own. Or actually, McDonnell Douglas did have the money, but they were freaking cheapskates. And they never liked to spend a dime, and so they wouldn't fund it internally to do that market. But those engineers built up their whole history, and they went on, and they now work or have mentored people and work at these companies and have enabled us to do this. So this really is everything we're seeing today at SpaceX, at Blue Origin, comes from this program. Again, NASA makes all this information available. It's a little bit harder to get because it's export controlled, but if you're an American working for an American company, it's easy enough to get a hold of. So all of that data, all of that knowledge is made available. Okay? Why? Why would you ever do shuttle? Keep in mind the last space shuttle launches were about $5 billion each. Yes, $5 billion each. And this is what happens when you burn out an organization and you're successful. So the Apollo program basically destroyed NASA. Successful, they landed on the moon. It was great for stimulating people to go into STEM, but as an organization, NASA couldn't do that. They couldn't sustain that. There was neither the desire to pay for something like that, to continue funding it, nor did they have the people to continue it. But they thought they could be successful. So their next step is they wanted a fully reusable launch system. And this is 1970. They didn't have the money for it. The US Air Force also wanted a fully reusable launch system. But those two desires only joined at exactly that one point. NASA wanted something that could go up into orbit, service a space station, bring down satellites, repair satellites, all of that stuff. The US Air Force wanted a vehicle that could launch spy satellites. So NASA wanted something that you would do at 28.5 degrees inclination, the US Air Force 93 degrees. But the other thing about spy satellites that's important is that we don't want people to know where they are. Now, back in those days, the satellite would go up, it had film canisters. It had 3 or 4 of those. Once they were depleted, they'd use the film, put it in the canister, drop the canister, get picked up by an aircraft. Once all of those canisters were used up, the satellite would deorbit. So the life of the satellite was in weeks. So it didn't have time for people to figure out. But if your launch vehicle stayed up for very long, you'd know where it was. So Space Shuttle had to be able to launch from Vandenberg Air Force Base, deploy the satellite, and return to launch site in one orbit. In that time, that orbit, the Earth moves approximately 1,000 nautical miles. You have to get 1,000 nautical miles across range. So that's why we have this shape. The original NASA designs were lifting bodies. They had about 200 nautical miles across range, because that's all you need coming out of orbit like Kennedy, because you're going prograde with the Earth. And we got this hybrid that made it vulnerable. We use solid rocket boosters, which have this tendency to blow up. We have this giant external tank, and we have a very delicate thermal protection system. And so all of that stuff combined to produce something that really was just a bad design. Okay. That brings us to the end of the pre-planned stuff. We've got some Q&A before we finish up here. Maybe. I don't know. Oh, did it go? So, first of all, what is my opinion on Elon, on SpaceX using stainless steel for the super heavy booster? Stainless steel is a great material. It's heavy is its biggest problem. The XB-70 was built of stainless steel. And the reason why is it has much better thermal properties than aluminum. Also, if you're going to reuse something and it's going to have a fatigue issue, stainless steel, like all steels, has a fatigue floor. Aluminum, the strength just keeps decreasing forever until it goes to 0. It will floor out on steel. One of the problems with working with stainless steel is, in addition to being heavy, if you weld it in the wrong environment, you destroy its properties. So they spent a lot of effort in the 50s and 60s developing these processes for using stainless steel. It comes in certain places. I think on the super heavy, it probably makes a lot of sense, but it's not a low-risk option. Thing about Starship, I think Starship's a huge mistake, is it isn't the same thing. It doesn't have the cross-range capability. It's not making all of those errors. The big problem, of course, is that joint for the folding fins. And that will be the make-or-break technology on it. If it works, great. If it doesn't, it could be a maintenance and long-term nightmare. The engines are also a problem. That many engines on a lower stage are asking for dynamic issues. Doesn't mean they're not solvable, but it's something to watch and a big risk. Is SLS now the most capital-consuming project? Space Shuttle had way longer to screw up and consume capital. SLS, if it continues and goes where NASA wants to, yeah, it'll surpass Shuttle. It's just silly. We're talking about throwing away RS-25s, which are extremely complex engines designed to be reused. That's the Space Shuttle main engines. They're just going to throw them in the bin. They're horribly expensive to make. Even with the improvements they're doing to lower the cost, they're still outrageously expensive. And there are probably better ideas. But it's a make-work project for parts of Alabama and Mississippi and Louisiana. What's my opinion on the newly announced Rocket Lab Neutron? I don't really have one yet. I haven't spent enough time looking at it, so I'll have to hold off on that. We'll get to my favorite aircraft in just a second. How is the X-37 different from the Shuttle? It's not a contribution. It sits on top of a rocket. It still has that cross-range capability because it has to be able to return to site. But it doesn't have the complexity of that buildup. You just put it on top of an Atlas V, and it's unmanned, so we don't have to worry about if things go wrong. How did Delta and Atlas rockets become part of United Launch Alliance? Lockheed and Boeing merged their programs as a service provider. Pure economics. Does the Falcon success rate count those that reflew and also landing failures? No, because it doesn't matter what happens to the rocket afterwards. We normally threw them away. Does it get the payload to where it wants to be for success? Don't know what happened to the Sea Dragon. What still prevents Strainer from flying? I'm not sure I get that question. Okay. What is Dr. H's favorite aircraft? So this is A1, and we'll talk about it. What are Dr. H's favorite aircraft? It's a better one, because there's actually more than one. And that will finish us up. .707, X-Wing, Valkyrie, C-42, Flying Banana. Oh, yes, the Flying Banana. Seki. I don't really have a favorite rotorcraft. Hurricane, the aircraft that actually won the Battle of Britain. Unsung hero. Death Star. So those of you who put the XB-70, yeah, that is one of my favorite. That's probably my favorite of all the high-performance aircraft. There's something about an aircraft design that's designed to cruise at Mach 3 in a short-sleeve environment and carry roughly the same payload as Concorde for about almost twice the meaningful range. Obviously, it was a failure in terms of what it was designed to do, but we learned a lot from it. It would have been a far better program had we not crashed the good one. What happened with the XB-70 is they had the first one, which had lots of manufacturing issues. It was limited to Mach 2.7 because above that, chunks tended to come off the aircraft due to issues with the stainless steel manufacturing. They had solved that problem by the time they built Ship 2, and that one was capable of long sustained flight at Mach 3. However, General Electric, who made the engines, the YJ93s, wanted to do a photo shoot with some of the other aircraft, so an F-4 Phantom, an F-104 Starfighter. And to make the photo shoot look really nice, they drooped the wingtips at low speed, which is perfectly fine, except for it generates massive wingtip vortices. That F-104 got caught in the vortice, came up, took out both of the vertical stabilizers and a chunk of the wing. The 104 disintegrated, pilot was killed, and the result was ship number 2 ended up crashing and being destroyed. So we kept the bad one, we destroyed the good one. Had we had that, we would have learned a lot more. None of you have put my favorite commercial transport up there. I haven't said anything about it, so I wouldn't expect you would. It is the Lockheed L-1011, and it was a horrible, horrible program. Lockheed lost money on every single one they built. Literally, they sold them for less than it cost to put them together, forget develop them. But it was an amazing aircraft. Stuff today, in terms of it was all analog systems, but had capabilities that they're just now incorporating or have in the last 10 years onto fly-by-wire aircraft. Some of these other ones are pretty cool. Gloucester Meteor, there's nothing wrong with that. Okay, so that's it for today. Next week, it is all you. So bring your questions, and we'll work through them. Otherwise, I ain't got anything for you, per se. Watch the video on how to revise, and we can talk about that and the like before. Okay, thanks, guys.